Implementation of BYD's Super E platform by Q2 2024. Date, March 17, 2025. Location, BYD headquarters Shenzhen, China. Overview. BYD has unveiled its pioneering Super E platform scheduled for implementation by Q2 2024, marking a significant advancement in electric vehicle EV technology. This initiative includes a robust investment of $150 million aimed at developing 1 megawatt 1,000 kilowatts charging infrastructure across over 4,000 charging stations, a move that promises to revolutionize the EV charging landscape and alleviate charging anxiety among users. Key features of the Super E platform. 1. High-voltage architecture. The Super E platform introduces the world's first mass-produced 1000V all-domain high-voltage architecture. This innovative design optimizes battery systems and motors, resulting in a 12% enhancement in energy efficiency by minimizing energy loss. This architecture is crucial for supporting the high demands of modern EVs. 2. Flash charging technology. The platform features ultra-fast charging capabilities with a revolutionary 10C charging multiplier, allowing vehicles to achieve a full charge in just 6 minutes. This translates to a driving range of approximately 400 kilometers in just 5 minutes, significantly outperforming competitors including Tesla, whose latest supercharger offers 500 kilowatts. 3. Next-generation motors. BYD has developed a high-revving motor capable of reaching 30,511 RPM, setting a record for mass-produced motors. With a peak power output of 580 kilowatts, this motor provides exceptional performance and power density, further enhancing the driving experience. 4. Silicon carbide power chips. These advanced power chips improve the reliability of the megawatt charging systems, which are rated up to 1,500 volts. This technology supports the high power demands of the new charging infrastructure, ensuring efficient performance. Launch of new models. The first vehicles to utilize the Super E platform are the Tang L EV sedan and the Tang L SUV. Pre-sales for both models commenced on March 17, 2025. With deliveries expected to begin in early April 2025. The pricing for the Tang L EV ranges from 270,000 renminbi to 350,000 renminbi, approximately $37,330 to $48,400, while the Tang L EV is priced from 280,000 renminbi to 360,000 renminbi. Both models are equipped with BYD's God's EYE smart driving system, featuring advanced hardware such as roof-mounted LiDAR, demonstrating BYD's commitment to integrating cutting-edge technology into its vehicles. Charging infrastructure deployment. A critical component of BYD's strategy is its megawatt flash charging network. Plans are set to establish over 4,000 charging stations, each equipped with 1,000 kilowatts capabilities. This network will utilize dual-DUN technology to enhance charging efficiency and adapt existing stations to support the new megawatt standard. Key milestones. March 17, 2025, announcement of the Super E platform and megawatt flash charging technology, alongside the pre-sale of the Tang L and Tang L models. Q2 2024, completion of the Super E platform implementation. April 2025, official launch and delivery of the Tang L and Tang L models. Conclusion and industry impact. The introduction of BYD's Super E platform is poised to redefine EV charging standards globally. By significantly reducing refueling times to match those of traditional fuel vehicles, BYD aims to boost the adoption of electric vehicles. The establishment of an extensive charging infrastructure and the introduction of high-performance vehicles underscore BYD's proactive role in shaping the future of sustainable transportation. This comprehensive strategy not only highlights BYD's technological innovations but also emphasizes the company's commitment to collaboration within the industry to enhance the EV ecosystem. As the market evolves, BYD's initiative is expected to set new benchmarks in the electric vehicle landscape. paving the way for broader adoption and integration of EVs into everyday life. Sources: 1. Electrek/electrek.co/2025/03/17/ bid confirms 1000 V Super E platform fast charging 400 km 5 minutes /overview of the Super E platform. 2. cnevpost/nevpost.com/2025/03/17/ bid new EV platform Han Tang L presales / details on the Han L and Tang L presales. 3. 5. Renew Energy Technologies /www.5revs.com/news/ BYD unveils megawatt flash charging Super E platform.html insights on the megawatt flash charging network. As BYD moves forward with its ambitious plan, the automotive industry watches closely, anticipating how these developments will influence the future of electric mobility and infrastructure. The implementation of BYD's Super E platform by Q2 2024 represents a significant shift in electric vehicle EV technology and infrastructure, particularly through its innovative charging capabilities and vehicle performance enhancements. The company's commitment of $150 million to establish 1 megawatt charging infrastructure across 4,000 stations reflects a strategic investment in not only EV technology but also essential supporting infrastructure. Counterintuitive information. 1. Charging speed versus traditional refueling. The Super E platform's 1 megawatt charging capability allows for a full charge in as little as 6 minutes, enabling a range of 400 kilometers with just 5 minutes of charging. This dramatic reduction in charging time may lead to a perception that EVs can now compete with traditional internal combustion engine vehicles in terms of refueling convenience. However, it is counterintuitive to assume that this alone will alleviate charging anxiety. Many consumers may still have concerns about the availability and accessibility of charging stations even with faster charging times. 2. High voltage architecture benefits. The introduction of a 1000 V all-domain high-voltage architecture is a groundbreaking innovation that optimizes battery systems and motors. While one might expect higher voltage systems to be inherently more complex and potentially less reliable, BYD's design actually reduces energy loss by 12%. This counterintuitive outcome highlights that increased voltage does not necessarily correlate with increased risk or inefficiency, but instead can lead to enhanced performance. 3. Market positioning against Tesla. BYD's announcement positions its charging technology as superior to that of Tesla's latest supercharger, which delivers 500 kilowatts. This competitive positioning is surprising, as Tesla has been a leading name in EV technology and infrastructure. The assumption that Tesla would remain the benchmark for charging capabilities may be challenged by BYD's rapid technological advancements and aggressive infrastructure rollout. 4. Perceived value of new models. The pricing of the new Han L and Tang L models, ranging from 270,000 renminbi to 360,000 renminbi, approximately $37,330 to $48,400, may initially seem high for an EV. However, when considering the advanced features such as the God's IV smart driving system and ultra-fast charging capabilities, potential buyers may find the value proposition compelling, suggesting that higher upfront costs can be justified by long-term savings and performance benefits. This challenges the conventional wisdom that cheaper vehicles are always more attractive to consumers. 5. A collaboration over competition. BYD's strategy includes inviting collaboration with industry partners rather than solely focusing on competition. This approach is counter to the often cutthroat nature of the automotive industry, where companies typically seek to dominate markets independently. BYD's openness to partnerships for enhancing the EV ecosystem suggests a shift in how companies can thrive in a rapidly evolving market. 6. Technological integration complexity. The integration of advanced technologies such as LiDAR and silicon carbide power chips into the Super E platform may lead to concerns about the complexity and potential failure points in the systems. However, The emphasis on reliability and efficiency presents a counterintuitive notion that sophisticated technology can actually enhance dependability when designed correctly rather than complicating it. 7. Energy storage usage. BYD plans to incorporate energy storage facilities at charging stations to ensure the 1 megawatt charging power can be maintained even in areas with limited grid capacity. This concept challenges the conventional view that charging infrastructure must solely rely on direct grid connectivity. Instead, it indicates a proactive approach to energy management that could enhance charging station viability in diverse locations. 8. Motor performance metrics. The introduction of a motor capable of reaching 30,511 RPM with a peak power of 580 kilowatts may seem excessive for typical driving needs. Yet, this high-performance specification not only stands out in the market but also subverts the expectation that EVs must be less powerful than their fossil fuel counterparts. This challenges the narrative that EVs are primarily about efficiency at the expense of performance. In conclusion, BYD's Super E platform and megawatt flash charging network aim to revolutionize the EV landscape, providing advanced technology that defies traditional expectations. The combination of ultra-fast charging high-performance vehicles and a robust infrastructure investment marks a pivotal moment in the evolution of sustainable transportation. The counterintuitive insights drawn from this development underscore the complexity and dynamism of the electric vehicle market as it matures and adapts to new consumer needs and technological capabilities. In BYD's announcement regarding the Super E platform and its megawatt flash charging technology, several critical elements are highlighted that could easily be overlooked but are significant in shaping the future of electric vehicle EV infrastructure and performance. Here are the key points along with their significance. 1. High-voltage architecture at 1000 V. Significance. BYD's introduction of a 1000 V all-domain high-voltage architecture is a pioneering move in the mass production of electric vehicles. This architecture optimizes energy efficiency by reducing energy loss by 12%. It is significant because it sets a new standard for EV design, enabling more efficient power distribution across various components such as batteries, motors, and power supplies. This high voltage allows for fast charging capabilities and enhances overall vehicle performance. The implications for manufacturers who do not adopt such technology could lead to competitive disadvantages in terms of efficiency and performance. 2. Flash charging technology. Overview. The platform's flash charging technology allows for a full charge in as little as 6 minutes, providing a range of 400 kilometers in just 5 minutes. Significance. This rapid charging capability addresses a major concern for EV users: charging anxiety. The ability to charge an EV in the time it takes to refuel a gasoline vehicle could significantly enhance consumer acceptance and adoption of electric vehicles. The development of such technology could change the dynamics of the automotive market by making EVs more appealing to a broader audience, particularly those who rely on rapid refueling options. 3. Next-generation motors. Feature. The introduction of a high-revving motor capable of reaching 30,511 RPM is notable, achieving peak power of 580 kilowatts. Significance. This advancement in motor technology represents a leap in performance capabilities for electric vehicles, enabling them to compete directly with high-performance gasoline vehicles. With the highest power density in the industry, this motor can offer superior acceleration and responsiveness. This could appeal to performance-oriented consumers and elevate BYD's status in the competitive landscape of sports and luxury EVs. 4. Silicon carbide SiC power chips. Impact. The new generation of SiC power chips rated up to 1,500 volts enhances the reliability and efficiency of the megawatt charging systems. Significance. Silicon carbide technology improves the thermal performance and efficiency of electronic components, which is crucial for high-power applications. The reliability of SiC chips in charging systems could lead to lower operational costs and improve safety, making high-power charging stations more viable. Furthermore, this positions BYD as a leader in the integration of cutting-edge technology that can influence the broader semiconductor industry. 5. Charging infrastructure expansion. BYD's plan to establish over 4,000 megawatt charging stations equipped with 1,000 kilowatts capabilities is ambitious. Significance: the strategic deployment of such a vast network of charging stations is vital for supporting BYD's electric vehicle sales and enhancing consumer confidence in EVs. This infrastructure growth aligns with global trends towards sustainable transport, potentially shifting the charging paradigm from low-capacity solutions to high-capacity systems. It also creates opportunities for partnerships within the charging ecosystem, impacting infrastructure providers and energy management companies. 6. Adaptive voltage management. Detail: the dual-gun technology and adaptive voltage management allow existing stations to convert to support the new megawatt standard. Significance: this adaptability signifies a forward-thinking approach to infrastructure. By enabling a smoother transition for existing charging stations to upgrade, BYD fosters collaboration and compatibility within the industry. It emphasizes the importance of flexibility in infrastructure development, which can help accelerate the adoption of high-power charging without requiring entirely new installations. 7. Market positioning with competitive pricing. Context: the pricing strategy for the Han LEV and Tang LEV, ranging from 270,000 renminbi to 360,000 renminbi, positions them competitively against other luxury EVs. Significance: this pricing strategy reflects BYD's intent to capture a significant market share in the fast-growing EV segment. By offering advanced technology at a competitive price point, BYD can attract a diverse customer base, from technology enthusiasts to environmentally conscious consumers. This could potentially disrupt the luxury automotive market, particularly for brands like Tesla. 8. Integration of smart driving systems. Feature: both flagship models come equipped with BYD's God's EYE smart driving system and advanced hardware features like LiDAR. Significance: the integration of advanced smart driving technology indicates BYD's commitment to not only performance but also safety and automation. This positions them to compete in the autonomous vehicle space, appealing to consumers looking for cutting-edge technology in their vehicles. The adoption of such systems could lead to regulatory advantages and partnerships in the future. Conclusion. In summary, BYD's ambitious rollout of the Super E platform and megawatt flash charging technology is poised to significantly alter the electric vehicle landscape. The overlooked aspects of high-voltage architecture, rapid charging capabilities, next-generation motors, and strategic infrastructure investments highlight BYD's innovative potential and its proactive approach to addressing consumer concerns and industry challenges. These developments not only set BYD apart in a competitive market but also signal a broader shift towards more sustainable and efficient transportation solutions. The ramifications of these advancements extend beyond BYD, influencing industry standards and consumer behaviors on a global scale. 1. Technological innovation in charging infrastructure. BYD's introduction of the Super E platform, featuring the world's first mass-produced 1000V all-domain high-voltage architecture and 1 megawatt charging capability, represents a significant leap in electric vehicle EV technology. This architecture not only enhances energy efficiency, reducing energy loss by 12%, but also allows for ultra-fast charging. With a 10C charging multiplier, vehicles can achieve a full charge in as little as 6 minutes, translating to a range of 400 kilometers in just 5 minutes. This technology positions BYD as a front-runner in the race for faster EV charging solutions, addressing one of the primary consumer concerns: charging time. 2. Market launch and vehicle models. The Super E platform will debut with the Han LEV sedan and Tang L SUV, which are set for pre-sale with deliveries expected in early April 2025. The pricing strategy for these models, ranging from approximately $37,330 to $48,400, aims to attract a broad consumer base. Both vehicles are equipped with advanced features like the God's IB smart driving system, which includes cutting-edge hardware such as roof-mounted LiDAR. This combination of performance and technology is expected to enhance consumer interest and potentially increase market penetration for BYD in the competitive EV landscape. 3. Charging infrastructure deployment. BYD's ambitious plan to deploy over 4,000 megawatt flash charging stations across various regions is a critical aspect of this initiative. These stations, equipped with 1,000 kilowatts charging capabilities and dual-gun technology, aim to build a robust and user-friendly charging ecosystem. By integrating energy storage solutions, BYD ensures that these stations can operate effectively even in areas with limited power supply. This strategic infrastructure investment not only addresses charging accessibility but also aligns with the growing demand for EVs, thereby facilitating a smoother transition to electric mobility. For industry impact and collaborative opportunities, BYD's Super E platform and megawatt flash charging network are poised to redefine EV adoption globally. By significantly reducing charging times and enhancing the overall charging experience, BYD aims to alleviate charging anxiety among potential EV users. Additionally, the open collaboration model promoted by BYD invites partnerships with other industry players, which could accelerate the shift towards a more sustainable transportation ecosystem. This collaborative approach not only enhances BYD's market position but also fosters innovation within the broader EV industry, setting new standards for charging technology and infrastructure development. In summary, BYD's Super E platform represents a transformative step in electric vehicle technology, combining groundbreaking charging infrastructure, advanced vehicle models, extensive deployment plans, and a collaborative industry approach to drive the future of sustainable transportation. Here are 3 famous historical cases that reflect transformative technological implementations and infrastructure developments similar to BYD's Super E platform initiative. 1. The adoption of the steam engine in the Industrial Revolution, 18th to 19th century. The steam engine, invented by James Watt in the late 18th century, was pivotal in transforming industries during the Industrial Revolution. This innovation led to the establishment of steam-powered machinery, which drastically increased production capabilities in factories. The proliferation of steam engines enabled efficient transportation systems such as steamships and locomotives, facilitating trade and movement of goods at unprecedented speeds. This infrastructure investment reshaped economies and societies, much like BYD's focus on revolutionizing electric vehicle charging infrastructure aims to do today. 2. The expansion of the interstate highway system in the United States, 1956. Initiated by the Federal Aid Highway Act signed by President Dwight D. Eisenhower, the interstate highway system was a massive infrastructure project that transformed American transportation. This network of highways allowed for faster and more efficient travel across states, significantly impacting commerce, suburban growth, and the automobile industry. The investment into this extensive infrastructure parallels BYD's commitment to developing a comprehensive EV charging network, which aims to facilitate the widespread adoption of electric vehicles by addressing charging accessibility and speed. 3. The implementation of the electric grid in the early 20th century. The establishment of the electric grid in the United States marked a significant technological shift, bringing electricity to urban and rural areas alike. The development of electrical infrastructure enabled various industries and households to access power, leading to innovations in manufacturing, communication, and everyday life. This foundational technology transformed societal operations and economics, akin to how BYD's Super E platform seeks to redefine the electric vehicle ecosystem through advanced charging technologies and widespread infrastructure deployment. These historical cases highlight the importance of technological advancements and infrastructure investments in driving societal and economic transformation. Similar to the goals of BYD's Super E platform initiative. Future outlook: BYD's Super E platform and the evolution of electric vehicle infrastructure. As BYD prepares to roll out its Super E platform by Q2 2024, the implications for the electric vehicle EV industry and broader transportation landscape are profound. With a strategic investment of $150 million aimed at deploying 1 megawatt charging infrastructure across over 4,000 stations, BYD is poised to redefine the EV experience, enhance charging capabilities, and stimulate market growth. Phase 1: Accelerated EV Adoption. The introduction of the Super E platform is likely to accelerate the adoption of electric vehicles globally. High-performance models like the Tang L EV and Tang L EV, equipped with advanced features and ultra-fast charging capabilities, will attract consumers who have been hesitant due to concerns over charging times. The ability to charge 400 kilometers of range in just 5 minutes will address charging anxiety, making electric vehicles more appealing to a broader audience. This phase could see a significant uptick in EV sales, particularly in regions where consumers are increasingly environmentally conscious. Phase 2: Infrastructure Expansion and Standardization. The establishment of a robust megawatt flash charging network will not only support BYD's vehicles but create a new standard for charging infrastructure across the industry. With over 4,000 charging stations equipped to deliver 1,000 kilowatts, the infrastructure will facilitate faster adoption of high-voltage charging systems. This expansion will likely lead to collaborations with other automakers and charging station providers to ensure interoperability and standardization of charging technologies, smoothing the transition to mass EV adoption and altering the automotive landscape. Phase 3: Technological Leadership and Competition. BYD's technological advancements, including a world-first 1000V architecture, 10C charging capabilities, and high-revving motors, position it as a leader in the electric vehicle sector. As competitors rush to match or exceed these innovations, the industry may witness a surge in research and development efforts focused on enhancing battery technology, motor efficiency, and charging infrastructure. This competitive landscape will drive down costs for consumers and spur innovation across the EV market. Phase 4: Global Influence and Sustainability. With its aggressive expansion and innovative technologies, BYD is set to play a crucial role in shaping sustainable transportation globally. The company's initiatives may inspire other regions and manufacturers to adopt similar charging standards and technologies, leading to a more unified global approach to electric mobility. The anticipated reduction in charging times and increased availability of fast charging stations will empower consumers to choose electric vehicles over traditional fuel vehicles, contributing to a decrease in carbon emissions and a shift towards greener transportation solutions. Phase 5: Future-proofing the EV ecosystem. As the EV market matures, BYD's proactive approach in developing high-efficiency components and establishing a comprehensive charging network positions it to future-proof its business model. The integration of smart technologies such as the BYD smart driving system will enhance the user experience and create new opportunities for services like autonomous driving and vehicle-to-grid energy management. This phase will also likely see a rise in collaboration with tech companies and energy providers to integrate renewable energy sources into the charging infrastructure, further enhancing the sustainability of the EV ecosystem. Conclusion: the implementation of BYD's Super E platform and megawatt flash charging network heralds a transformative era for electric vehicles and charging infrastructure. With a focus on rapid charging solutions, advanced vehicle performance, and a commitment to sustainability, BYD is set to lead the charge in redefining the future of transportation. As the company rolls out its technology in the coming years, we can anticipate significant shifts in consumer behavior, industry standards, and global EV adoption, paving the way for a cleaner, more efficient future in mobility.